Hi, I'm Eric Beeler.
I'm James Smith.
I'm Maddie Mingo, and our project is Enhanced Response for a Defibrillator Simulation. Our project is sponsored by the SDSU College of Nursing's Healthcare Simulation Center, and our faculty advisors are Mr. Michael Tweed and Dr. Leanne Horsley. Lifelike simulation devices are becoming an important part of nursing education. Realistic simulations in controlled environments help future nurses prepare for upcoming professional challenges. During a simulated defibrillation, the mannequin does not respond to the shock. However, in a real-life code defibrillation, the human body jolts upward in response to the energy delivered. For this project, our goal is to design a device that triggers the mannequin to jump slightly after the shock from the defibrillator has hit the mannequin. We also want to find a solution that works with the College of Nursing's existing technology. Our goal is to build this device as well as 3 replicas, one for each College of Nursing location, within the project budget of $1,000. We also hope to offer additional features that can be included with the device, while noting that these additional features may exceed the project budget.
This project is significant because more than 500,000 cardiac arrests occur each year in the United States, according to the American Heart Association. The odds for those who suffer cardiac arrests outside the hospital are very bleak. Less than 10% actually survive, and those who do often come out with serious neurological damage. Delayed defibrillation is associated with lower survival rates. One large U.S. study showed that 39.3% of patients defibrillated in under 2 minutes survived to discharge, compared to 22.2% who were defibrillated after 2 minutes. With this project, we hope to give College of Nursing students a more lifelike reaction to help them prepare for real-world scenarios.
As far as our procedure for this project, we are utilizing the 6-step engineering design approach. This consists of an idea, concept, planning, design, development, and launch. Currently, we are finishing up the design phase and going on to the development stage.
As stated before, the idea is to integrate our device into existing equipment used during nursing simulations. On the right is a hospital headboard, which is removable and placed underneath the patient for added stability during CPR. Below that is the CAD model of the hospital bed with an arbitrarily drawn square of the device's size. As we do not want to cut into the hospital headboard, we decided to use a clinical cart backboard shown on the left. These backboards are significantly cheaper than hospital headboards, which will help keep the cost down. We are also exploring the option of creating a custom backboard that fits perfectly with our device. Because this device is placed behind the back of the mannequin, it must have a low profile so that it will not cause any instability during CPR. A device must be powerful enough to provide a strong upward movement. The amount of force needed is much more than most of the small servo motors that are currently on the market. By using potential energy, which can be released quickly, we can achieve the desired movement. A strong enough spring or piston, when stored in compression or tension, will provide the movement that we want.
The 2 pictures shown are 2 different angles of our scissor jack design. The picture on the left shows the scissor jack in an isometric view. With this picture, there would be 2 jacks that would produce an upward force onto the mannequin. The picture on the right shows a front view of the scissor jack. With this design, the spring would hold the scissor jack in compression until the lock is out of place. As soon as the lock is out of place, the scissor jack would boost upwards, pushing the mannequin as what would happen with a defibrillator force. Then, when the nursing students go to do CPR onto the mannequin, it would bring the scissor jack back into compression, giving it that flat profile. From here, the scissor jack would lock.
When thinking of an idea on how we wanted to trigger our device, we turned to one of our professors, Mr. Sternhagen, on how we could use a voltage differentiator on the mannequin when the shock is applied. The idea of this is that when the shock is applied, we'd have wires connected to the nodes on the mannequin, and that differentiator would sense the change in voltage, which in turn would send a signal to our mechanized device. This idea allows a quick and reliable reaction to simulate a realistic shock. And currently there is no competing design on the market for this type of device.
This is our project schedule. Currently, we are in the design phase, about to move on to the prototyping phase. We hope to start buying materials for the prototyping phase and work on this throughout the summer. These are our references that we use for this presentation, namely for our statistics within the project significance slide. If you have any questions regarding our project, feel free to email us at the emails listed below, and we would be happy to answer those questions. Also, feel free to leave a comment in the box folder, and we would be happy to answer those questions as well. Thank you for listening to our presentation.